Hello everybody, this is Unit 5B, Video 1. We're going to be using the fundamental trig identities and working with those today. Alright, so this is a little bit of a reminder here for you. We have the sine of theta equals y over r, and the reciprocal of sine is that the cosecant of theta is r over y, and we have to just make sure that y does not equal 0, because it's in the denominator. Our cosine is x over r, and the reciprocal, the secant, is r over x. Of course, x does not equal 0. The tangent of theta is y over x. X cannot equal 0 because it's in the denominator. And the cotangent of theta is x over y, and that's when the y can't be 0 because it's in the denominator. Well, where does all of that come from? If I'm looking at the sine and I were to just draw a triangle here in the first quadrant, and this can be applied to all 4 quadrants, the only thing that changes is the positive and negatives applied to each of the values, that the distance traveled in the horizontal direction is x, the distance traveled in the vertical direction is y, and your hypotenuse is r. So if I'm given 2 of those values, I can find the third by using the Pythagorean theorem, x squared plus y squared equals r squared. So no matter what, I'll be aware of 2 of the values, and I'll be able to find the third, which will be able to help me find all 6 of our trig functions. Let's go ahead and show you how this is going to work. Here we're given the sine of theta equals 5 over 13, and we know that this is in the second quadrant. Find the other 5 trig functions. Well, I'm going to start by just drawing a triangle in the second quadrant, as it tells me, and that my sine value, which is my vertical and my hypotenuse, is 5 over 5 and 13. To find the missing side here, which is my horizontal value, my x value, I will go ahead and use the Pythagorean theorem. So I have 5 squared plus the x squared will equal 13 squared. When I solve this, I come up with x being positive or negative 12. Well, since I'm moving to the left, I know I'm going to be using negative 12 as my value. If the directions say to state the other 5 trig functions, sine of theta was given as 5 over 13. Cosine of theta is negative 12 over 13. We just found the negative 12. Tangent of theta is 5 over 12, a negative 12, and the negative really belongs in the numerator, even though it is technically on the 12, the value is negative 5/12. Then I have my cosecant, which is my reciprocal, so 13 over 5. Oops, I forgot the other c. Then I have secant of theta, which is 13 over 12, and again, I'm moving the negative to the numerator. It's the most proper place to put it. And lastly is the cotangent of theta, which is negative, and then 12 over 5, just the reciprocals. So to repeat the process of what we just did is first we drew the triangle where it told us the triangle was located, labeling the 2 parts of the triangle that we were aware of. We used the Pythagorean theorem to find the third side, and because it went left, we used the negative x value. Then I found the other 5 trig functions because the first one was given to us. Let's try the next one. Here I'm told that the tangent of theta is negative 3 over 7, and it's in the 4th quadrant. So let's go ahead and draw our triangle in the 4th quadrant. I know that my opposite is negative 3, and this is 7. Now that negative could have applied to the 3 or the 7, but because it's in the 4th quadrant, I know that my vertical direction is negative because it went down. So now I need to find the other 5 trig functions. The sine of theta, I need to find my missing side of my triangle. So I've got negative 3 squared plus 7 squared equals my radius squared. So that's 9 plus 49 equals r squared. 58 equals r squared. There's no perfect squares hiding inside of 58, so I can simply leave that as the square root of 58. All radii are positive, so you'll never find an r value that's negative, even though when you take the square root you should get positive and negative. We're only using the positive value. So this leaves me with an opposite of negative 3 and a hypotenuse of root 58. We will rationalize, so this is negative 3 root 58 over 58. The cosine of theta is 7 over the square root of 58, and when rationalized is 7 root 58 over 58. Tangent was given to us as negative 3 over 7. Now I need to find the reciprocal functions. My reciprocal functions, it's easier to use the non-rationalized one because then when I flip it over, I get the square root of 58 over 3. I'm going to apply the negative to the numerator. It doesn't matter, but it's most proper in the numerator. My secant of theta is the square root of 58 over 7, and my cotangent of theta is negative 7 over 3. Again, I'm applying it to the numerator even though it looks like it's on the 3. Alright, let's keep going. Okay, so the next one they gave us the secant, and they told us that the sign is negative. So we're going to have to figure out what quadrant this applies to. Now this says that the sign is negative, and this tells us that the secant is negative, which really tells us that the cosine is negative. So if cosine represents my x and sine represents my y value, and the information given tells me that they're both negative, there's only one place where both the x and the y are negative, and that's in the third quadrant. So even though it didn't state it's in the third quadrant, we have to use the information we know about where sine and cosine are positive and negative. So here's our angle, and this 9 is my r value, but it's not negative. It's the adjacent that's negative. And when I use the Pythagorean theorem, negative 2 squared plus my y squared equals 9 squared, 4 plus y squared equals 81, then y will equal the square root, or y squared will equal 77, and so y equals the square root of 77. That is also going to be negative because it's located in the third quadrant. So let's find the other 5 trig functions. My sine of theta, based on this triangle, is negative root 77 over 9. The cosine of theta is really the reciprocal of what they gave us, so negative 2 over 9. My tangent of theta is negative root 77 over negative 2. Well, that means that my negatives are going to cancel, so it is the square root of 77 over 2. Now I'm going to go ahead and I'm going to have to rationalize some of these. So the cosecant of theta is going to be 9 over root 77, and it's negative, which becomes negative 9 root 77 over 77. Secant was given to us as negative 9 over 2. And my cotangent is the reciprocal of my tangent, so that is, after rationalization, is going to be 2 root 77 over 77. And that one is also positive because both the x and the y are positive. Alright, doing great.